Hey everybody, Dr. Pingle here with a quick lecture on vector file structures. Actually, this one may not be so quick. Unlike vector, which was probably a review for just about everybody, this one is probably fairly new. So let's get right into it. First of all, there are a lot of different kinds of vector files. So most of the time when we work with vector files, we're either using things like Shapefiles, which is a pretty old data format, or else one of the many varieties of geodatabase, which has gotten a little bit more popular since Esri introduced those quite a few years ago at this point, but they've been a little slow to catch on. However, there are a lot of different kinds of vector formats. This is just a small collection of them. If you're interested in checking out the whole list, we've got a link here that you can use to take a good look. So the list is pretty big, as you can see, and it really is growing all the time. One of the kind of unfortunate things about this business is that basically file types don't really go away. We just invent new ones. So the list of what you kind of need to know keeps growing, although there really only are a few that are really very, very important, and we'll talk about a few of those today. A couple of those already you can see on this list. So the comma separated value is right here. Esri shapefile right here. Maybe one that you don't know is GeoJSON, which we'll be talking about. KMLs, quite a few different kinds. So let's take a look. By far the most common is the shapefile. So the shapefile is actually a collection of a number of different files. So it's one of the most misleading things, I think, when students are first learning about GIS. They think, they know that they need to load a shapefile, and they may start to think the shapefile is the .shp file. And that is partly true, but actually the shapefile contains at least 3, but generally about 6 different files that all work in concert to display the data that you look at when you load something up on your GIS. Esri actually invented this, so this is an Esri proprietary format, although it's gotten to be the de facto standard for most of the data that you'll find out there. So if you're downloading vector files, there's a very good chance that what you're looking for is going to be available in at least shapefile, if not a couple of other formats. This format, again, is pretty old. It was created in the early 1990s. As a result, some of the limitations that you run into in terms of especially things like what columns can be, what they can be named, is a little bit annoying. But it still is kind of the standard. As much as many of us would like it to go away, it doesn't really look like it's going away anytime soon. The base format is actually defined by 3 different files. These are something that you really need to know. It's something that you'll be tested on, so it's good to know these in some detail. So the 3 files that are required are the .shp file, the .shx file, and the dbf file. So the .shape file, shp, is the one that actually holds the featured geometry. So when you load a point, or you load a line, or you load a polygon, this is the file that contains where those vertices are located. The dbf file is the file that's going to control, or hold rather, all of the attribute information. So the population, the GDP, the area, all of this extra stuff that gets that when you load your attribute table you get to see, that's where this stuff is located. And then the third is the .shx file. This is the one that kind of ties everything together. I like to call it the glue file. This is the one that essentially acts as an index, helping to kind of link and smooth out your experience when you load the data and are searching on things and all of these kinds of things. So those are the 3 that are required, and those 3 you need to know. There are a couple more that are optional. Some of those that are optional that you'll see pretty often are the .prj file. So this is a projection format. This is usually going to contain information about the coordinate system and the projection. What's really interesting is this is what's called a plain text file, meaning you can load it in a text editor and take a look at it visually. And the projection information is stored in what's called a well-known text format. That WKT we'll see here again as a way to keep track of other kinds of vector data. One of the most common extra pieces that you'll get is this one. So this is the .shp.xml file. So XML is extended markup language. This is kind of an extra file. It also comes in, it also is going to be in plain text format. But this file you can open using a text editor. You can actually bring it into a browser, web browser. And it usually is going to contain metadata information about the data set that you're looking at. That can often be very helpful in terms of figuring out sort of how to work with it. One of the big questions that people have when they're working through this material is why they need to know this in such detail. And one of the things about this is that GIS is a lot more than just clicking buttons. It's really important that you understand kind of the basis of what you're doing. And the reason for that is that it's very easy to run into trouble when you're working in or with GIS. By now, you've had enough lessons on your own that you've opened dialog boxes and you've seen prompts to supply parameters that maybe you don't fully understand. The more you understand how the system works kind of under the hood, the more you're going to be able to deal with those kinds of problems as they come up. So it is very important that you learn this information. It will come back and you will use it, I promise, if you're going to be working in GIS for very long. All of this kind of stuff comes in handy for me on a daily basis. One of the things that you can do is take a look at the Esri Shapefile technical description. So this is available online and you can download it as a PDF. It contains a lot of extra information and it's certainly a very technical document. But one of the things that you can get out of that is sort of an exposure to sort of the nuts and bolts in terms of how GISs are constructed. One of the things that you can find is that you'll find references to things like this, where a shapefile stores integer and double precision numbers. The remainder of this document will refer to the following types: integer, assigned 32-bit integer of 4 bytes, and a double assigned 64-bit IEEE double precision floating point number. Floating point numbers must be numeric values. Positive infinity, negative infinity, and not in number values are not allowed in shapefiles. All of this kinds of data is super important and will affect how you store data in it, how you interact with it. And so it's good to know what some of these terms mean. And we'll be talking about integers and doubles and floats and not numbers soon enough. Okay, so let's take a close look at each of these kind of in some detail. So the first one is the .shp file. This is sort of the shapefile of the shapefile, and it's going to contain again the geometry information about what you're looking at. So the coordinates of the points or the lines or the polygons. This is where all that information is stored. The binary file itself is going to contain what's called a header. So with all of this extra, with all the information in a file, what they try to do is they try to put information about that file at the beginning. So that's going to do things like tell you what kind of a file it is, whether it's point or polygon and so on. And then after that, you're going to have what are known as variable length records. Different shapes will have different geometries, different lengths. This polygon may only have 4 points, but maybe the next one has 500 points. So it's the variable length part of this that lets it be different sizes. This is sort of a snapshot of what that looks like. This comes directly out of the Esri shapefile spec. So this is going to contain a 100-byte header. So again, header information, sort of like the table of contents of the file, letting you know a little bit about what's inside of it. It's going to contain information, again, about the shape type, so whether it's a point, a line, or a polygon. And it's also going to contain what's called a bounding box. So a bounding box is going to be a series of coordinates in X and Y, but also potentially in Z, and potentially also in what's called an M value, or a measured value. And what that does is that helps, it increases the ability to do things like searching. So if I've got a few different shape files, all containing geometries over different parts of the world, if I only have to sort of look at the header to sort of see, okay, what area does this shapefile pertain to, that's going to speed up my my data processing, and so that's the reason why these headers are important. Again, sort of like looking at the table of contents in a book and seeing what topics are covered, and if it's not relevant to whatever you're working, you can toss that book aside and pick up the next one. Those different kinds of data come up all of the time. So anytime you want to run a tool on a vector class, it's going to be important that you at least know what data type you're working with. Some kinds of types can play with different kinds of data types, but most of the time when you do operations, polygons are going to be interacting with polygons, and so on. Plenty of exceptions to that, but generally speaking. So this is an example of the create feature class tool. So you can see that you can create points, multi-points, polygons, and polylines, and we'll dive into those differences here in a second. Most of those, again, you've seen before, but we'll talk especially about the point versus multi-point. The two values that we had just mentioned, we have Z values. So these are typical measures of elevation. Most of the time, it's still a little unusual to record points in 3D space. So if you're dealing with things like the boundaries of countries, generally what we do is we specify the X and the Y coordinates, the latitude and the longitude. But what we don't specify is the elevation associated with those. We imagine that they're all sort of on the surface of the Earth, and so we don't specify an elevation. But it's important to know that you can. So shapefiles are capable of accommodating 3D points in sort of their native format. So if you're working with things like a LiDAR scan, which has what's called a point cloud, points in 3D space, shapefiles can actually be used to record those point clouds directly. The other one is called an M value, or a measured value, and you'll see this sometimes towards the bottom. So this is at the bottom of that create feature class. So has Z and then has M. So again, measured value, this is something else. This might be a kind of attribute data, for instance. If we were measuring, for instance, barometric pressure, we might measure that at a latitude, at a longitude, but also at an elevation or a height, and then that might have a particular value, 1,000 millibars or whatever it is. So it's important to know that the binary part, the geometry part of a shapefile can actually hold all four of those types of information. Generally speaking, those measured values, and even occasionally the Z values, are going to be found in the attribute data rather than in the geometry data. But good to know that it's possible. This is actually a full spec of the different kinds of things, and again, mostly this is just a combination of point, polyline, polygon, and multi-polygon with various permutations of adding Z or adding M. The one here at the bottom that you might catch in on is what's known as a multi-patch. We won't talk about that, but I'll let you use your imagination for what that might be. One of the really interesting things about shapefiles is that almost always they are required to hold, or almost always in reality, they hold the same kind of data. So if you download data on rivers, for instance, every single record in that shapefile is going to be a line. Now, what's actually interesting about this is that if you go into the very base specification, there's room before each kind of shape that appears in a shapefile to define the shape type. So at the 0th byte position at the very beginning of that variable length record, you can actually redeclare the shape type. So it's technically possible for a shapefile to contain more than one shape type. You have to be careful about how you're going to word this bet. So if you're going to make a bet with your GIS friends someday, make sure you say that it is possible, not that it's often done. This is the exact line that comes out of the specification file. So possible, but not currently used. One of the big questions, so points, lines, polygons, those are all pretty clear and probably fairly well covered in your earlier GIS classes, but multi-point may be something new. So multi-point is going to be the idea that you can record multiple points on essentially a single record. So this is going to be a thing that has a single object with multiple locations. This doesn't actually come up very often out in the wild, but it's good to know that it exists because there's a good chance that if you work in GIS long enough, you'll run into something where this happens. We can show you an example of what that looks like. So this is a feature class that I've created within ArcGIS. We've got a couple of just random locations here, and the squares, the black squares, we've got 1, 2, 3, 4, 5, 6 different points. But if you go to look at what that would look like in the attribute table, those 6 points are declared as a multi-point, and they all exist as part of the same record. So if I start to attach attribute information about this, it's going to be attached to all of these points sort of simultaneously. A more common way to represent that data is this way. So you would have point data instead. Each point has its own line in the data set. And then you could potentially have an attribute column that tied all of these things together to let you know that those are all part of the same object. So points are much more common than multi-points, but it's good to know that they exist. I'll let you sort of think a little bit about what the implications of that would be. When you might want to use the multi-point data structure, how you can replicate that behavior, which we actually just talked about. So you could just assign another column here with an attribute information, and then use all of these 6 could have the same value here, so they could all be assigned to 0 or all be assigned to 1, and that would help you link all of those together. The creation of data is one of those things that I think sometimes gets a little bit overlooked in GIS courses. Many times the data that we work with kind of gets handed down to us, often in the form of data that comes with our exercises or data that we go out and look at in the wild. But it's good to know how to create this stuff, and so there'll be assignments related to that in this course. It's pretty easy to make all of these. So when you create that feature class, you can go in and edit it, and then you can use the editor toolbox to create these as you go. One of the things, even though we call these things points, lines, and polygons, the line itself is actually what's known as a polyline. Unlike points, it's actually fairly common for linear features to sort of separate out and to not sort of just be a single line segment, let's say. So what's cool about the polyline is that we can have multiple segments being a part of the same line. So the easiest way to sort of imagine that is something maybe that looks a little bit like this, where we've got maybe something like a branch of a river. This is another sort of easy feature that I've sketched up in ArcGIS. So you can see that at the top I've got 2 different lines. One of those lines is selected, so you're seeing that as the FID6 line that's highlighted. Here at the bottom we've got 2 lines, both are selected, so those are 5 and 6. But what we can do to make those features go together is to use the merge toolbar. So lots of different places for this, but you can find it among other places in the editor window, so merge. And when you do that, those 2 pieces will come together, and now what was 5 and 6 is now just 5. Those 2 pieces have formed one single polyline. Even the one at the top, just a line, but all of these go into the same type polyline. So good to know that that's sort of the technical term for that. 2 pieces do not need to be connected to be the part of the same polyline. So at the bottom we had this fork. So it's easy enough to imagine, okay, these are part of the same structure. But they do not need to be linked to be part of the same structure. So I've repeated those steps. I've selected the bottom part and the top part and gone to merge those 2 things together, and the result of that is the formation of a single feature, now with FID4, just a single polyline with 2 disconnected parts. Polygons are pretty common. I'm sure you've worked with them pretty extensively. But we want to dive in a little bit and talk about sort of the difference between, or what maybe the polygon specification can do that maybe you haven't done yet. So one of the cool things about polygons is, first of all, they can be disconnected, but second of all, they can contain holes. So this comes out of part of the spec. So it says that the polygon consists of one or more rings. So those rings would essentially be what you would think of as different polygons. So maybe Alaska as one polygon, the continental United States as a second polygon, if you were being fairly coarse about it. A polygon can contain multiple outer rings. So that's just to say that you can have multiple sort of polygons a part of the same multi-polygon, let's say. But you can also, as I said, have holes inside those polygons, and we saw an example of that with the OpenStreetMap building a few slides ago. So the order of vertices is what's going to specify whether a polygon is going to be sort of an outer ring or an inner ring. I don't necessarily need you to remember clockwise, counterclockwise. Oftentimes you have to look those things up, but it's good to know that they're sort of different orders, that the outer polygon is defined one way, and it happens to be clockwise, and the holes are going to be defined by a different direction, and those happen to be counterclockwise. This is an example of kind of what the structure looks like for a polygon within the shapefile geometry file itself. So it's going to contain information about the bounding box. So we talked about each shapefile itself is going to have a header that describes a bounding box that encapsulates all of the features in it. But you're also going to have a secondary structure that at the front of each polygon is going to tell you what the bounding box for that polygon is. So again, just sort of speeds up operation time to do it that way. You're going to have the number of parts, the number of points, and then a listing of those parts and points as you move through the polygon. So there are a couple of major things that a polygon has to have to work correctly within GIS. So first of all, the rings have to be closed, which is to say that the first and last vertex of the shape need to be the same. So you can't have any open polygons. Second, the order of the rings in the points array is not significant. So we're going to see that how we specify them in terms of clockwise or counterclockwise is important, but the indices aren't. And then the last one is that the polygons stored in a shapefile have to be clean. This is one of the test questions that I like to ask. What is a clean polygon? So a clean polygon has a couple of requirements. One, it has no self-intersections. So you can imagine that you could sort of sketch up something that would wind up like an hourglass shape, where you sort of doubled back and crossed over the line. That's not allowed. We want to make sure that polygons are all sort of work in regular geometric space, and there's no sort of doubling back. And then the second is that the inside of the polygon has to be on the correct side of the line that defines it. So this is really going to boil down to sort of making sure that the holes are counterclockwise and the outer parts are clockwise. This is sort of a nice example of what that looks like. So here we have sort of this diamond-shaped polygon that has an outer ring and an inner ring, or a hole. So the vertices are specified in a clockwise order. They start up here, so there's vertex 1, there's vertex 2, vertex 3, vertex 4, all moving again clockwise rather. The inner piece, the hole, goes counterclockwise, so here's 5, 6, 7, and 8. Now, those themselves, as you can plainly see, they are specified in a clockwise order. So that's why this is the part that says that the index value doesn't necessarily matter. It's how they're going to appear within the spec that matters. So we're going to have two parts to the polygon that are going to be written into the file. And these are going to be integer values that tell me sort of where those parts are going to start. So we're going to have one part start at 0. We're going to have another part start at position 5. within a lot of computer programming languages, we count all of our things starting at 0. So 0 through 9 are our positions. We have 10 positions: 0, 1, 2, 3, 4, 5, and so on. So as we're going to try to describe this particular shape, we're going to start with the outer ring. So there's our vertex 1, 2, 3, 4, and again, the first and the last have to be the same, so it's closed. And then when we want to define this hole, we're gonna start with that V5, but then we're gonna move in a counterclockwise order. So here's V8, there's V7, there's V6, and then back to V5. So we're obeying our tenet that we have to start and stop at the same spot, but we're moving through each of these in a counterclockwise way. So even though the vertices themselves are sort of appearing in a clockwise way, we're specifying them. It makes no difference whether those are clockwise, counterclockwise, or entirely scrambled, so long as when we write them into the file this way, we're putting them in a counterclockwise fashion. Okay, so that's the shape file. Then we have the SHX file. So this is just an index file, so the X corresponds to index. This is, we don't get into too many details about this. This is a fairly small file in most cases. Whereas in comparison, a lot of times the geometry, particularly when it's fairly intricate, can be fairly big. So this is an example of boundary files that I pulled from Natural Earth. And here the shape file is relatively large in size, so just over a megabyte. The index file, the SHX file, in contrast, is really small, only 4 kilobytes. We'll skip over some of this detail. I wanted to give you an example of what this sort of looks like. But if it's enough to know for these purposes that the SHX file is an index file, that you need it, and that it helps sort of improve performance when interacting with the shapefile. The last one that you do need to know something about is the DBF file. So the DBF file is the third of the 3 required files. This file is important because it's going to hold all of the attribute information. So when you go to look at the attribute table of a shape file, this is the file that you're pulling it up from. When you pull open that attribute file, it's actually pretty common for you to see geometry sort of compressed. You'll see that first entry is just sort of like point or polygon or whatever it is. And that's because what you're really looking at here is really just sort of the DBF file. The DBF stands for D-base file, which is essentially database file. This is a fairly old specification for storing what we would call tabular data. Anything that's sort of held like a table is kind of the root of that. Because this is fairly old, and Esri actually brought this in, sort of recycling existing database technology. And again, because this is fairly old, there are some fairly severe limitations about what that DBase file could do. It first appeared in 1979, so that's a long time ago. So one of the things that is particularly limiting is the column information. However, one of the great advantages of using a DBF file is that DBFs, because they're essentially just a spreadsheet file, they can be opened and inspected in just about every spreadsheet software out there, including Excel. They used to be editable. They're still technically editable, but modern versions of Excel, because this data format is actually so old, they're trying to stop supporting that. So try it, and I'll show you an example of this in the applied part of the lecture, but double click on your DBF file, and it'll ask you what program do you want to use to open it. Try opening it with Excel, and you'll see it appear just as if it were a normal spreadsheet, which is actually really handy trick to use when you want to run some quick statistical analyses and don't want to bother with ArcGIS. Almost all of the time when you're working with shapefiles, you're going to see an additional file that comes in called the PRJ file. So this file contains the projection. One of the cool things about this is that you can bring it into any text editor. So Notepad is a good one. Notepad++ is a good one. And you can just bring it straight in and take a look at it. And down at the bottom here, we've got an example of what that would look like. And even if it seems a little bit dense, you can start to sort of figure out some of what's going on here. So we've got information about the datum that's being used, the North American datum of 1927. We know what spheroid we're working with. We can see what the prime meridian is that we're working with, which is almost always going to be Greenwich. But very cool to sort of be able to just quickly take a look at it and see what's kind of, again, going on under the hood. The format for these kinds of specification is, again, the well-known text format, WKT, and we'll see an example of how you can use that format to store geometric information, so a lot more than just the projection. Okay, so that was a good description, sort of the nuts and bolts of how shapefiles work. One of the things that we should definitely talk about is why and why not shapefiles. So shapefiles are one of the oldest vector file formats out there, still in active use, especially. And even though they are old, and even though they do have limitations, they are what we would call the de facto standard. And this can be leveraged in a lot of really interesting ways. So, for instance, if you're looking for geodata, one of the great things that you can include in a search is the word shapefile itself. And because shapefile is really unique to GIS, you're almost sure to get to the spot that you need exactly, rather than just sort of looking for things like geodata or vector layer. The word vector can be used in a lot of different contexts, and so it doesn't necessarily using that word is not necessarily going to take you to the right place. So not only are they sort of in use and easy to find, but every GIS that you're ever going to use, well, maybe not ever, that you're likely to use, is going to be able to read and write shapefiles. They're really the lingua franca of vector formats. They're in wide use, and so it's kind of one of those things. If everybody else is using them, then maybe you should too. However, there are some really key limitations to shapefiles that make them pretty awkward to use. Certainly Esri would like to try to get away from shapefiles if possible. This is a data format coming out of the early 90s based on databases from the 70s. And we can do a lot better than that now. So some of the specific limitations, and these are good things to know. One, they don't store null values very well. So for any time you want to keep track of information, there's a good chance that you may not have a particular value for it. So like, let's say you're keeping track of, you've got a vector layer of countries and you've got a population column. Well, you may not know the population of every country in that database, and so sometimes you're just going to have to key those things in as a null value. Unfortunately, shapefiles don't support null values. There are things called not a numbers, which are often used to denote missing data, and shapefiles can't use those. And so what you end up having to do is to record a specific value and letting it know that that's a null value. So oftentimes you're going to use something like -9999 as kind of what we would call a flag or an indicator that you're missing information there. You have to be very careful when you're running calculations, though, because you want to make sure that if you're doing sort of trying to figure out the average population for all of the countries, that you don't just calculate that -9999 as if it were a real number. Otherwise, you're going to wind up with problems. And there really is no number that's going to solve that problem, right? Whether you record that as 0 or 100 million, no matter what number you use is going to throw off the calculation. So what we really need is a data spec that allows you to record an I don't know or a null value natively. And we've got plenty of alternatives now that we can use, but shapefiles can't do it. Second one is they round up numbers. So this is a sort of a precision problem with the way that the numbers are stored in the database. So you just have to be a little bit careful about the values that you use inside a shapefile. Probably a bigger limitation, as far as I'm concerned, is this one. They have poor support for Unicode and non-English and special characters. So it used to be that English was kind of the dominant language for programming, for databases, and so on, because a lot of those technologies were invented in the United States. Well, now that technology has diffused all over the world, and there are certainly requirements that your spatial databases can accommodate what are even not such special characters anymore. They're things that are kind of used all the time, and shapefiles have difficulty handling those kinds of things, and as a result, you end up having to sort of encode these things as if they were English characters, leading to some problems. This is probably the worst one as far as I'm concerned. They don't allow field names longer than 10 characters, and none of those characters can be spaces. So this is one of the reasons why the census data records all of their data in terms of these keys. So DP0010001 is total population. Why don't they just say total population? Well, that's more than 10 characters. The spaces isn't such a big problem. You can use other characters to sort of act like spaces. You can just merge all of the letters together, and most people can still read it. But the 10 characters is a pretty severe limitation, and one that's often difficult to kind of work around. That can be especially a problem if you are doing things like joining information from an Excel table. So Excel definitely does not have that limitation, and the shapefiles do. So if you join that data up and you try to export it as a shapefile, you can run into problems with that. And then finally, this is a fairly minor one. They can't all store both time and date in a field. So you can store the date in one field, you can store the time in another field, but you can't store them in the same field, which can make some time calculations a little bit tricky to do if you need to sort of buffer on both. Buffer here in a temporal way, not a spatial way, but if you want to sort of draw a line around, I want everything within 2 days and 5 hours. It can be a little bit tricky to kind of to code that up and to make that query. Still possible, just a little bit more annoying. So there's your quick, or maybe not so quick introduction to shapefiles. Again, a lot of the information that you've been presented with here seems like a lot of detail, and in some sense it is. But these details come up all the time. It's really important to know, for instance, that shapefiles have this limitation of 10 characters. It's really handy to know things like you can load the DBF file directly in an Excel file and take a look at it. So a lot of little tips and tricks that we talked about here will reinforce in the application section of that and reinforce on part of your assignments. But I hope you found this interesting, and stay tuned for further lectures on vector data formats. We've got to talk about the well-known text format, GeoJSONs, and keyhole markup. So thanks for listening.